Hi everyone, my name is Chandana Gajjala, and today I'm going to talk about something we all use almost every day, like text prediction. So, what exactly is text prediction? In simple terms, it's when a computer or a machine tries to guess the next word or phrase you are about to type based on what you have already written. So, for example, when you type I'm going to the means your phone might suggest words like store, gym, park, when. So the text prediction at work. Now, how does it actually do that? Well, these systems are powered by models that learns from huge amount of text data. They study how words usually appear together and recognize patterns in language. So, when we start typing, the model uses what it has learned to predict and what word is most likely to come next. So it just matches the next sentence or whatever the sentence we have typed there, it just matches the word. So we can see the text prediction used in so many places, type assignments on our phones, email suggestions, tools, translation apps, and even in conversational AI systems like ChatGPT. So in short, we can say um, text prediction makes our typing faster, smarter, and more convenient. It like having a little language assistant built into our devices. So, so moving on, why text prediction? Why did we choose this topic? So we choose text prediction because it's a really interesting mix of language understanding and deep learning. It's not about predicting words, it's about how computers actually learn to understand human languages and context. So for me, I'm Chandana Gajjala, and I found this topic fascinating because it connects both technology and communication, two things that impacts our daily life so much. So text prediction isn't only a cool computational challenge, it is also like a huge real world value. Like it helps people type faster, express their thoughts more easily, and even access information more efficiently. Like if you want to tell something to the people, and if you are typing the sentence, and if you think that it is not reliable to the thing what we gonna say to the person, but this chat prediction helps to type the information more efficiently. And the best part is this concept forms the base for many advanced AI technologies like we are using today, like machine learning, translation, text summarization, and question answering systems. So we can say that we choose this topic because it's both technically exciting and practically useful. It shows how AI can truly make human computer interaction smoother and smarter. So now let's talk about how text prediction actually works. As its core, text prediction models learn statistical patterns from large language data. So basically, they study how words usually appear together and use that knowledge to predict what comes next. So, in earlier days, we had something called n-gram models. These models were pretty simple and they used probabilities based on previous framework. So, one of my teammates Satish will explain what's Ngram model and how it is works.
Hi, now I'm going to explain how Ngram Ngram workflow works. Ngram models predict the next word based on the previous few words. First, we do tokenize, splitting text into individual words. Example, I love natural language processing. Because I love natural language processing, it's a split words. So then we create a n-gram, groups of n constitutive words. For example, with n is equals to 2, a diagram, we get pairs like I love natural languages. So we could how often each word group appears in the text. Next, we calculate probabilities. For example, if it was raining heavily, appears often the model predicts rains after the it was heavy. Finally, the model chooses the word with the highest probability. This means the illumination is the n-gram only can remember a few words so that they do not understand the terms context concept. So next, I'm going to explain how modern approaches. Modern text predictions uses deep learning models trained to huge text databases. The main models are RNNs and LSTMs and transformers. RNNs reads the words one at the time and remember previous ones, but they forget when the sentences got long. LSTMs are important. RNNs then use gates to remember information for longer. Transformers are the most advanced used in the GPT and BE at these use self-attentions, which helps the models look at the whole sentences of once. For example, in the animals did not across the road because it was tired. The transformers knows that it refers to the animals, not the road. Transformers understand the concept much better and makes more accurate predictions. And transformer architecture, the transformer architectures have two main parts, which is encoder and decoder. Encoder is used for the wait and decoder used for the GPT. Workflow for the text prediction. Decoder like GPT input sentences is tokenized like I am going to the tokens are understood into the vehicles used embedded. Portions encoded adds order for order information. Self-attention layers that each word look at the other to the learn concept. Feed forwards layers process and refines the information. Softmax layer predicts probability for possible next words. The model picks the word with the highest probability. This process repeats until the model forms complex, meaningful sentences. And the next one is applications. Virtual assistants like Alexa, Siri, and Google Assistants use it to understand and complete commands. Chatbots are used in the generative human like meaningful responses. Predict keyboards use it to suggest your next word or even a full sentences while typing. Translate tools like Google Translator use it to predict the most accurate next word across language. Text predictions is now part of everyday life, helping machines communicate more natural with the us. So next challenge is going to be one of my teammates going to be explained.
Thanks, Satish. So, we have heard what text prediction is. I'm going to talk about the problems we still face and what's new and what's next. Even though these tools are smart, they have big challenges too. First, ambiguity and context. Words can mean different things. For example, bank can be a place for money or the side of a river. The AI can get confused about which one you mean. Second, bias. This is a really important one. AI models learn from the internet, and the internet is full of human biases. The AI can learn these same stereotypes, and that's a problem we need to fix. Third, computation. The best AI models are used. They need giant, powerful computers, which cost a lot of money and use a ton of electricity. And coming to the next slide, the biggest new thing is transformer-based models. Is the technology inside tools like ChatGPT. They are much better at understanding the whole sentence, which helps them get the context right. Next, there is a fine tuning. We can take a giant all purpose AI and do a little extra training too. An expert in one specific subject like medicine or law. To fix the bias problem, we use reinforcement learning from human feedback. This just means real people can check the AI answers, reward the AI when it gives a good, helpful, and honest answer. This teaches is to be safer and less biased. Finally, it's not just about English anymore. A big trend is multilingual prediction. So the AI can work in many different languages. Coming to the next slide, the future directions are First, accuracy. We need the AI to be correct, not just sound good. The goal is to stop the AI from hallucinating or making up facts. Second, accessibility. We want these tools to work for everyone on any device. The big goal is to make it work offline, so you don't even need an internet connection. And that's only possible with efficiency. This fixes that computation problem. We are working to make AI models smaller, faster, and use way less power. This makes them cheaper for everyone and better for environment. So, coming to the last slide. So, to conclude, this technology is becoming a key part of how we talk to computers. So, we have seen it has real challenges like bias and how much power they use. But new trends like transformers and human feedback are helping us fix them. The future is to make these tools more accurate, easier for everyone to access, and more efficient. Thank you so much.